Section 5.2 Problems. Problem 1. Find the value of each of the 6 trigonometric functions of angle theta in the figure. Okay, so we have a right triangle here with one side labeled 4, one side labeled 3. The hypotenuse is unknown. So first we'll use the Pythagorean theorem. The length of one side squared plus the length of the other side squared equals the length of the hypotenuse squared. So 16 plus 9 equals the length of the hypotenuse squared. So 25 is the length of the hypotenuse squared. So taking the square root of both sides, the hypotenuse will be 5. So this is a 3, 4, 5 triangle. Okay, so this triangle here, get this right, 4 there, 3 there, and 5 there. And that matters because theta is here. So we want the 4 to be the adjacent angle theta. So there's our right triangle, and we want the 6 trigonometric functions of that angle. Okay, so we'll get the sine of the angle. So here's the angle. Look through it this way. Put the eye right through there. Opposite length 3, hypotenuse 5. If you know the value of the sine, immediately you know the value of the cosecant because that will be its reciprocal. So you can get that one right away. Without even using the definition, you could just use the reciprocal identity. The cosine of the angle is the adjacent length, so that'll be 4, divided by the hypotenuse 5. So that's 4/5. Knowing the cosecant immediately gives you the secant to be its reciprocal, so that'll be 5/4. And then the tangent of the angle is the opposite length, opposite 3, adjacent 4, 3/4. Therefore, the cotangent of the angle is its reciprocal, and that will be 4/3. And there's the 6 trigonometric functions of angle theta for problem 1. Okay, let's take a look at problem 2. Find the values of the 6 trig functions of angle theta. Express each in simplified form. Okay, so let me transfer this over here. We have right triangle. I know the way I draw them always looks like a 45, 45, 90. Figure not drawn to scale. This is 5, this is 1, and this length here we don't know, so this is B. I'm going to write a capital B there. Lowercase b's look like 6's. So let's first find the length of that side right there. So side 1 squared plus side 2 squared equals hypotenuse squared. So b squared plus 1 is 25. So b squared is 24. So taking the square root, b would be the square root of 24. Square root of 24 we can simplify to be 4 times 6. I'm choosing 4 and 6 so that we can break that up to be root 4 times root 6. So 2 square root 6 is the length of side B. So I'll put that in here, 2 square root 6. Okay, now we have all 3 lengths. So now it's a matter of just writing down the answers to the 6 trig functions and simplifying if need be. So we'll do the sine. Now we'll see, I didn't have angle theta here. Angle theta is in here in the corner. So I have to put angle theta here in my diagram. So sine of theta is the opposite length to the hypotenuse. So that's 1/5. Therefore, the cosecant of theta will be its reciprocal 5. The cosine of the angle is the adjacent length, 2 root 6, divided by the hypotenuse 5. Now, the secant of the angle is the reciprocal. So that's 5 divided by 2 root 6. Okay, now we're going to have to rationalize that a little bit. So let's come here and do that. Secant of the angle, 5 divided by 2 root 6. So I'm going to multiply by root 6 divided by root 6. All I need is to get rid of the square root in the bottom, so I do not need to multiply by 2 root 6 over 2 root 6. As long as you multiply by 1, it'll work. So the numerator becomes 5 root 6. The denominator becomes 2 times 6. So this will end up being 5 root 6 over 2 times 6 is 12. Okay. If you multiply by 2 root 6 divided by 2 root 6, then you'd have a little bit of simplifying here to do. So let's see, how are we doing? We got the sine, we got the cosecant, we got the cosine, we got the secant. Okay, so we just need the tangent and the cotangent. So we need tangent. Tangent is the opposite divided by the adjacent, so that's 1 divided by 2 root 6. Okay, so if we take 1 divided by 2 root 6, rationalize by multiplying both top and bottom by root 6, we'll end up with root 6 divided by 2 times 6, or root 6 divided by 12. So there's the tangent. Now, listen. You want to get the cotangent of the angle. The cotangent is the reciprocal of the tangent. But if you make the reciprocal of this, you'll have to rationalize again because you'll have a square root in the bottom. You'll have 12 divided by root 6. So instead of reciprocating this, reciprocate this, and immediately you have the answer 2 root 6. Much easier that way. So let's see. Sine, cosine, cosecant, secant, tangent, cotangent. We got them all. So there are the 6 trig functions for problem number 2. Problem number 3. Use the right triangle to find the cosecant of 45 degrees. Okay, cosecant of 45 degrees. Well, 2 ways to do that. The cosecant of 45 degrees, you can look at the right triangle definition, which is the hypotenuse divided by the opposite. Okay. Look through your angle of 45 degrees. Now here there's 2 of them, so it doesn't matter which one you look through. Say we look through the one at the bottom here. Hypotenuse root 2, and the opposite is 1. So that's root 2 over 1, or root 2. You could also use the fact that the cosecant of 45 degrees is 1 over the sine of 45 degrees. Okay? The sine of 45 degrees is the opposite length divided by the hypotenuse. Okay? So look through 45 degrees, opposite is 1, hypotenuse is root 2, 1 over root 2. When you reciprocate 1 divided by 1 over root 2, you get the same result as before, root 2. So either way there, you can find the cosecant of the angle. Okay, next problem, number 4. Use the right triangle to find tangent of 60 degrees. Tangent of 60 degrees is, look through this angle right through here, opposite length, root 3, divided by the adjacent length, 1. Root 3 divided by 1 is root 3. Problem 5. Given the value of sine theta to be 2/3 and cosine theta to be root 5 divided by 3, find the tangent using a quotient identity. Okay, so the quotient identity here referred to tangent theta is the quotient of sine to cosine. Okay, and both of those values we have. The sine is 2/3 and the cosine is root 5 over 3. Okay, so we simplify that complex fraction, numerator times reciprocal of denominator, 3 over root 5. We'll end up with 2 over root 5. Multiplying top and bottom by root 5 will rationalize or remove the square root from the bottom, and we'll have 2 root 5 divided by 5. So that's how we get the tangent. Now, if by chance you wanted the cotangent, if you reciprocate this, you'll have to rationalize again. If you reciprocate this one, you're done. Root 5 divided by 2. Problem number 6. Given that sine theta equals a half, theta is an acute angle. That means less than 90 degrees. So you're in quadrant 1 right there. Find the value of the cosine of the angle using the trigonometric identity, the Pythagorean identity. Sine squared plus cosine squared is 1. Okay, so let's get the identity. Sine square angle plus cosine square of the angle is 1. Now remember, this is short for writing sine of the angle squared. So this is short for sine of the angle square plus cosine of the angle square is 1. Now the sine of the angle is given to be 1/2, so substitute that in. The value of sine theta is 1/2, that has to be squared. Plus cosine square is 1. So you're solving for the unknown, which in this case is the cosine. Half square is a quarter, so cosine square is 1 minus a quarter, taking the 1/4 to the other side. Finding a common denominator, get 3/4. So then the cosine of the angle will be plus or minus the square root of 3/4 plus or minus root 3 over 2, square root of top divided by square root of bottom. Now, how do you know which one that you wish to have? Well, the angle theta is an acute angle. It's less than 90 degrees. So since it's an acute angle, then this means that we have quadrant 1. And in quadrant 1, cosine of the angle is positive. So the value for cosine theta that we will choose is the positive square root. Okay, so that means that if theta were an obtuse angle and we are in quadrant 2 the cosine's negative. So we would choose the negative answer of root 3 over 2. If we were in quadrant 3, again the cosine's a negative, so we choose the negative answer. And if we're in quadrant 4, we choose the positive answer since the cosine is positive there. When you see cosine, think x-coordinate. When you see sine, think y-coordinate. So always think helpful cosine, always think x-coordinate. When you see sine, always think y-coordinate. And that thinking will be very helpful as you do trigonometry. It's true, cosine is not defined to be the x-coordinate, but always think about cosine linked to the x-coordinate. And that's how quickly I can go through here discussing in which quadrants your answer will be positive or negative. Okay, let's go on to next problem, number 7. 7. Okay, this one we did in the PowerPoint, so let's do a new number 7 here. Let's do cofunction for the cotangent of 83 degrees. Okay, it's difficult to make these challenging in any way. The cofunction to cotangent is tangent. Tangent and cotangent are cofunctions. Therefore, the tangent of 90 minus the given angle, I'm using 90 because we are in degrees here. 90 minus 83 is 7. So the tangent of 7 degrees is exactly the same thing as the cotangent of 83. These are exactly the same, exactly the same. Okay, number 8. We'll have to do a new one here as well. Find a cofunction with the same value as cotangent pi over 12. Let's do the cosecant of pi over 7. Cosecant of pi over 7. Okay. We want a cofunction. The cofunction to cosecant is secant. Now, since we're in radians, 90 is pi over 2. 90 minus the angle. Okay, now I'll just work that out a little bit, find a common denominator. So this is the secant of, common denominator would be 14, 7 pi over 14 minus 2 pi over 14. Okay, so the cosecant of pi over 7 will be the same as the secant of 7 pi over 14 minus 2 pi over 14 is 5 pi over 14. They'll be exactly the same. Secant and cosecant are cofunctions. Yes. And that concludes the problem set for section 5.2.